And there, I've got a class set of these dev board sticker trackers, but today I'm just going to use one of the original ones. This is the rack clip, and it only has 4 wires on. The red is 3v3, the black is ground, and they're on the back pins here. On the rack clip, it's the red is on the first pin there and the 4th pin. And then RX and TX are on the first of the front and the second of the front. That matches up with this part. And there you can see RX, TX, 3v3, and ground. And then we've got the rack DAP1. And it also has the connections. You can kind of see them there. So we've got the black is on ground, the red is on 3v3, and on the other side we've got the RX and TX. And that's plugged in. The hard part is actually getting the clip lined up and then it not moving. So I'm just going to try here. And we get the little pop-ups. I love those DAP pop-ups for debugging, but I haven't quite got this one working yet. Anyway, we are trying to do this IMU, so acceleration X, Y, Z. So we just got to make sure the port's in the right place and fire that onto the board, and it looked like it just dropped out, so let's try it again. There we go. Now, where we got this stuff while that's compiling, this is, my original course is the Maker 100 course, but this one is the Maker 100 Eco, meaning it's slightly cheaper and has 2 boards. It's got the Chow and the RAK2270. This is near the end of the course because these things are getting a little bit advanced. And we are doing number 63, those numbers might change, the rack acceleration IMU, okay? And it's got a little bit of a blurb there, but basically the code is right here. You can click on this button and view the code online. There is an include file. You better install that properly. This course isn't about libraries at the moment, but we could probably, you'd go to Manage Libraries and check for that exact SparkFun one. So the board is compiled and lost my screens. That was the screen I was looking for. It's detecting the baud rate because I haven't gone in here and set it to boot, but it actually worked. That's a little bit on the rare side because I probably set it to boot before setting it up. We'll go through that. Here it's installing the code. Let's have a quick look at the code. That's super important. That's setting my IMU to be in the right kind of area. There's the code actually running, which is always nice. The X location on the board and which way is X. You don't actually know until you move it, and it's really hard to move with that. So what I'm going to do for my students, I'm going to solder some wires on so we can actually do some of the IMU stuff. But this is the important part, is the Z is positive 9.8-ish meters per second squared acceleration. If I turn it one way, I can figure out which one's the Y, and if I turn it the other way, I can figure out the X. So what I'm talking about there is right now it's like this, but if I turn it like that, one of those values is going to become 9.8. If I turn it like that, one of those values will become 9.8, and you can figure out your X and Y. That's the perfect thing for the students to do. That's pretty much the assignment. To begin with, at Z just resets it. At plus boot puts it into boot mode, which is where it was originally, and I probably should have shown that. And if you want to ever get out of boot mode, it's at plus run. Okay, and that stops boot mode, runs it again, kind of like at Z, which just resets it and runs it again. Super important, the baud rate. It seems really sensitive, unlike other Arduinos. Get the baud rate proper. Some example code has the baud rate at 9600, and that does kind of mess things up, so be aware of that. This is all just setup stuff. Nothing really exciting there. That's super needed, my IMU begin. And then we're looping, we're grabbing some floats, we're reading the float X, Y, and Z. I'm just doing a little bit of math there to change it from, what's it changing it from? It is making it like an acceleration due to gravity instead of just a decimal number. And then this is printing it, that's printing it to 2 decimal places. This is not the best way to do a print line, but it's the easiest for students to understand. That just prints the X, that prints the X value, that prints the Y. Get your pluses in the correct place, best just copy it. You're welcome to change the delay making it faster, and that's the whole program. Have a good day.